Okay, um, this is the fourth video for the fan portion, and coming from the third video, we have all the spiders made. We have the 1D connections. The fan is assembled. The only thing it's not connected is between the 2D handle to the 3D 2D blade portion to the 3D blade. Okay, we didn't put anything between those two meshes, so if you do anything now, the top portion is going to fly away. Alright, so actually we don't connect them in the fan. Okay, we have something very nice that will glue them together. It's called gluing, and that is in the simulation. So that brings us to the sim here. Now we're in the sim, okay? And before that, you should check all the connections for your fan. Show adjacent to check them, okay? And if you need also to do a show the element edge to see if they are merged together, those two mirrored piece. And what else is you can also change this navigator into a material view. Okay, standard, now we're in a standard view. We can change that to material view. Then that's all the material we use for this model. And we have steel, nylon, and something that's no material. That is your spiders, the bushings. Okay, we can turn that off. So what we got for the nylon, okay, that's actually the nylon bar here. Then what's for the steel? That's everything else. Okay. So this way you can check if your model is good or if you missed some material. Because sometimes if you turn this no material on, you see a 2D mesh collector. That's not good. You need to give the meshes material. Anyway, let's switch back to standard view. So that's all the preparation you need to do before you come to the sim. And now in the sim, we need to connect those two pieces together. I think I already did this. Okay, so we're going to do this again. And I'm going to delete them first. And delete those. Alright, so how this gluing works is we have this edge to surface gluing. Okay, and we're going to glue this 2D sheet, the edge on this 2D sheet to the face on the 3D mesh. So the way it works is first you need to create regions. So region and target region, right? The region will be in this folder, region folder. You can create them on the fly in this command. Okay, so edge region, you can create a new region here. That is one way. The other way, you can just right click on the region and create a new region. So let's open the fan tree here, turn off stuff we don't need. Okay, so first we're gonna create two edge regions. So we don't need 3D. So we actually need to just select that edge here. So right click and new region, and we have types. You can create an edge region first, then you actually just pick one edge of one element. So we needed to use some clever method. Feature element edges, then click one edge, it'll pick the whole thing. Okay, so let's name this so we remember which side is which. So let's say this is the right side. We can say edge region. If it says 1, we'll say right, and apply. Then select the other one. Again, it's the same method. Element, feature element edge. And that's the left side. apply. Then the next is the surface region. Okay, so we will turn off this, show those two. Alright, so this is on the right side. Again, we need some method. You don't want to hand pick everything. So feature angle element face. It will select anything within certain angle. So we pick one. It'll bleed through the whole face here. And the name is also, this one is on the right side. I'll say right. Then next is on the left side. The same method. Just say L. Okay. So let's turn the mesh back on, turn this into static wireframe. See where are the regions. So one is here. It's hard to see. Turn this to black. Yeah. Maybe this. You can see it's highlighted. Then turn off the light. Okay, those two. Then left and right region. Okay, so now let's insert edge to surface gluing. So usually, usually if you do a surface to surface gluing, you want the source to be finer mesh. Now here the region is already selected. Source is edge, so you have to pick edge no matter what. So the edge region is right side, surface region is also right side. Okay, those two. And the search distance, if your edge region and the surface region has a gap, okay, this search distance, if the search distance is bigger than the edge, NX will think they are glued. And if it's smaller than this search region, or the gap is bigger than search region, you will think, okay, they're not close enough. Anyway, so if you do apply, you can see some funny things. Okay. So those arrows are indicating they're trying to search for the elements that'll be glued together. And we can do the same for the left side. You can just pick from here and say okay. And those are the display of the gluing. So here we just finished putting everything together. Okay, and the load, actually we have, this model is already done. So load is 10 pounds, and load is right at the very end of the handle, pointing each other. So let's try to show you how to make them. An easy way to make them is hide a half of the handle. Okay, so you're gonna pick the node at this corner because that's the symmetry plane, that's the center. Now we're gonna apply a force, 10 pounds, and the direction you have to define it yourself. 2 points from this point to the other point, right at the end, the middle of the handle. And select object, apply on the same node, this node. Say apply. So that's the one force. Then you need the other one on the opposite direction. So this node and the vector defined by 2 nodes from here to, again, this point. Okay, so that's your force, 10 pounds, equal and opposite. And if we turn this mesh back on, you can see it's right in the middle. Alright, then constraints, and you can constrain for the fixed constraint. We can constrain anywhere actually, but just to see the blades coming in together, we will grab the center of this nylon bar. If you grab the center of this nylon bar, when you have the animation, the the blade will come in symmetrically with respect to the center of this nylon bar. So that's what we want. And that's actually not enough for this model. There's a mechanism here. Is remember, we didn't put any bushing between the C-bar to the 3D element, and even that, this C-bar can rotate on the 3D element. The reason being is the 3D element doesn't have rotational degree freedom. So if you just connect to one node here, it still can rotate, even though they share a node. Stiffness cannot be transferred into the 3D texture. So what will happen is, if we grab the center of the nylon bar, the 3D can still rotate, and the whole thing, okay, your whole snip will rotate like this, clockwise or counterclockwise. So this is why we need another extra constraint here to kill the displacement on Z direction. So it's like, if you're looking at this direction, it's like this is the center of the circle and everything can rotate with respect to this point. So if you kill the tangential direction degree of freedom, which is the Z direction, this whole thing will stay put. So that's why we need this extra direction. User-defined constraint, kill DOF3, that's the Z direction. And by the way, you can pick any point on this handle. And also we want another point on the other handle. The reason being is, if you only have one, and our blades is not symmetric, the whole snip will twist a little bit. If you grab those two nodes, it will not twist. So actually, in real life, if you use a scissor, it's very old. It has a gap between the blades. You can feel it's twisting a little bit. So, but just for the simulation, we can kill the twist by picking up two action constraints. So apply here. So now in total we have 3 constraints. One is a fixed, okay, and the other 2 are the user-defined that kills the Z direction, and that'll prevent the snip to rotate on the nylon bar, also prevent the twist. Okay, so that's all you need for the in the sim, the gluing load constraint. And now you can actually run this simulation. Let's do a model setup check. So it's just a warning, it's fine. Okay, and before you do a simulation, when we do a hand calculation for this, we need to compare the force in X on the pins. How do we get the force in the pins out of NX? We create a group, a new group. You will create a new group. Okay. Then open up the 1D collectors, open up ZBrush. You don't have to hold any shift or control, just click. Okay, it's automatically multi-selecting the elements. So we need all of the ZBrush elements plus the nylon bar. So this will write the force in nylon bar into FO6 file, and in that you have the axial force, so you don't have to interrogate the force in the GUI interface. Okay, so we need 6 elements for the group. Name it whatever you want, and I have one already here. It's the bushings actually with the nylon bar. So now the same thing here. Then we do a solution. Then you want to edit the attributes, case control, output request, And here we will turn on SPC force to print, of course. Then one thing extra is the force. Turn on the force and put that on print. However, we don't want all the nodes. That's way too much. So we want the entity to be output as a group. Which group? That'll be the one you just created. Okay, so bushing of the group 1. And let's see, SPC force, don't need displacement. Yeah, that's it. Just turn on SPC and then turn on force. Then you can run the simulation and hope you didn't mess up with the pin joints. It'll give you no results. Okay, and it'll take a little bit time because we have what do you call that? Parabolic 3D tetra, and even just that little bit, take longer than most of your homework. And before we use a 3D tetra for the whole blade, that actually takes about 2 minutes. Alright, let's take a look at the results. Okay, F8, play. So as you can see, the tip of the snipper is not really the ideal place you want to cut something, right? You should put it in the middle. And there's no twist. It's a little bit still there. So that looks legit. And if you look at the spiders, they are rotating with respect to each other. Okay, they should be rotating like this, and this one too. Alright, so that's a simulation, and you still need to get something out of it. Let's edit this post view here. I think it's here. Okay, header. Okay, that's what you need to do. Okay, so for the final report, post view, right click post view and edit. In this legend, display header, change that to customized. Okay, and click. The header is what's showing it here. You need to turn on the next line and type in your name here, and type in your NID here, whatever that is, and take a screenshot for your report. This way we know this model is made by you, at least at this part. Okay, and say okay. Say okay, it'll have something here. Okay, so that's the header. What else? What else is the FO6? Okay, so remember we turned on the bushing force and the C-bar force. And if you open FO6, oops, too many. Alright, let's turn on this again, go all the way to the bottom, then go up a little bit, then you have the force in the bar element. Okay, and don't look at those in the front, doesn't matter. Axial force. Here axial force is negative 30.7. So negative, that means compression, which is right. It's about 30 pounds. So if you squeeze 10 pounds, you get 30 pounds at the tip. And apparently at the end of the blade, it'll be very huge. And the bushing force, okay, you have those bushing force here. Every element corresponding to one pin here. Okay, each pin, the force in each pin is in this bushing elements. And also, one thing you should be noticed is the sign here is not necessarily useful. because the bushing, as we know, bushing is only 1 point. Even though we gave it absolute coordinate system, the value can be flipped. So it can be -9 and +9 here. It also can be 9 and -9. So it depends. Okay, some people get negative, some people get positive. And that's really it. Then you have the SPC force. And you want to have really small number on the fully constrained, the constraint, because this our load is equal and opposite. You should have, theoretically, you should have nothing on the fully constrained constraint. So on the fixed constraint, so -5 is good, -2 is okay because it's twisting a little bit, and also this one, that's because of the twisting. And if you take out one of the Z constraints, it'll be really small. Okay, but it will bring up twist, which is realistic. Okay, so that's the analysis of the FO6 file, and you will be asked to hand calculate all the forces in the joints, and that's the forces in the joints. You'll be asked to compare your hand calculation to the pushing force here, and also the axial force in the bar element. All right, so that's all for this video.